This is part 3 of medical physics dealing with PET scan, which is positron emission tomography. So, what's the basic working, how it works, how radio traces are made, and what type of questions you can expect from this topic. We're going to get covered. We're going to cover that in this topic, in this slide. Okay, so working. How does it work? First, the basic idea is that previously we use X-ray and CT scan or ultrasound to look inside the body from outside. This technique involves visualization of the internal tissue from the inside. Why we're saying that? Let's get to that. So the basic idea is that we introduce a positron particle or a positively charged electron inside the body by using a radioactive element or radioactive fluorine, which combines with the which combines with the glucose molecule and makes a radioactive glucose molecule, which is absorbed by the body at different parts, at different locations, wherever glucose is needed. Now, the idea is that the cancer cell, usually, what part is called cancer? Those parts which produce, which are under high cellular activity or are rapidly multiplying, are called cancer cells, generally, right? Or called a tumor or referred as a tumor. So, since they have a high activity, that means that they are going to absorb glucose from bloodstream much more rapidly or much more at a higher rate in comparison to the healthy cells, right? So as a result, what happens is that this radioactive glucose molecule is absorbed by those cancer cells or highly active cancer cells, and as a result, they show up at a higher activity than the rest of the cells present in that area, generally leading to the identification of where the tumor is. Okay. So first, we need to make a radio tracer. Now, radio tracer, as the name suggests, it is going to be radioactive in nature, and it is going to help us trace where the tumor, where the cellular activity is high. So we make this from the device called cyclotron. You don't need to remember this, but the way it is made is a part of your course. Okay. So what we do is we have a stable oxygen atom. We accelerate proton in a cyclotron and then throw it towards a stable or a neutral oxygen atom. This results in the creation of radioactive fluorine. Now, this radioactive fluorine is injected into the body. When it does, this decays through a process by releasing beta particles, which are positively charged, which are positrons, right? So this fluorine, which is 18.9, decays to give us a positively charged beta particle, which is called positron, hence the name positron emission tomography. And that positive beta particle interacts with another beta negative particle, which is inside your body, because body is made out of chemicals, it's made out of elements, it has electrons as well. So radioactive fluorine gives out a beta particle, positron. It combines with the beta negative that is already present inside the body, and then because of the process of annihilation, it gives off two gamma ray photons that are going to be released in the opposite direction, because mass, energy, and momentum are going to be conserved in this nuclear process. Now, first we look at the syllabus. We understand that what is a tracer, right? It's a radioactive nucleus introduced into the body, absorbed by the tissue being studied. So we understand this point number one. Point number two is that radio tracer decays to give us a beta positive particle, hence the name, of course, positron emission tomography. You understand that as well. Point number three, annihilation occurs. Now let me show you what annihilation looks like. This is what annihilation looks like. Now this negatively charged particle or electron was already present in the body. This positively charged particle, which is called a positron, was injected into the body from the external source, and this was created in the cyclotron, right? Now when they combine, they annihilate each other, because one is matter and one is antimatter, and they undergo a process called annihilation. We need to remember this name as well, because we have to mention it in the examination marking scheme. And as a result, they emit two gamma ray photons. They are going to move in the opposite direction. And in this nuclear reaction, mass, energy, and momentum are conserved. Hence, we get to this conclusion that the energy produced by the photons, or the energy of the photons, and the momentum of the photons will exactly be equal to the energy or the mass of the particles that are interacting, which is this electron and this positron. Okay. All right. So we understand point number 3 as well. Okay. Point number 4 is that in PET scanning, positron emitter, decay, and tracer annihilate. They interact and produce gamma ray photons. We have discussed that point as well. Okay, so we can calculate the energy of the gamma ray photons emitted during the process as well using this equation, which are going to be a part of your syllabus. And we've done these equations previously in quantum physics as well. Now, what happens, how the imaging actually takes place, how the image is formed. You see, when this annihilation, let's say, occurs at this point, two gamma ray photons exactly opposite to one another are emitted in different directions. Now, the time taken for this particle and the time taken for this particle are measured and calculated because we know that they are moving at the speed of light. So using speed equals to distance over time, we know the speed of the particles, we know the distance, we don't know the distance, but we know the time when this might have taken place. So we backtrack this distance from this location and from this location, and then we can pinpoint the exact location where this particle, where these photons must have originated from. So based on this data, we understand to exact depth where this particle actually is going to come from, or wherever the activity of gamma ray photons is higher than the rest of the body. Okay, so this basically lights up those areas which have tumor, which have cancer, because cancer and tumor cells absorb glucose much higher as compared to the rest of the body. And since that glucose is radioactive because this fluorine has combined with it, that's why they show up or get highlighted in the examination. Okay, so we understand this point number 5 as well by using those equations. Okay, and then pinpointing those locations, I've discussed that point as well, that how we pinpoint where they are going to come from, where those photons come from, and what location in the body gets highlighted because of that, in exactly what part the tumor or the cancer cell lies. These are the points of summary taken from the book. Just memorize them, right? And this is what the answer, or this is what the question is going to be about. Okay, so an example question taken from October-November 2023 is represented over here. It says, state what is meant by tracer. Again, tracer element, the definition is this. It is introduced in the body and it is used to detect where cancer or tumor cells are high. Then he is going to ask you, then he has asked about these particles. Primarily, this is a decay question that we have already done in nuclear physics. So he says, what is X? We know that O is oxygen. So, and since this is positron emission tomography, PET scan, this should be a positron, okay? So I can write down this as beta positive or electron with a positive charge. Then we move towards P. What's P? Now we know that beta positive goes something like this, 0 plus 1. So P should be plus 1, okay? Then we have Q and R. So Q is over here, then Q is 0, okay? And R, since charge and mass are conserved in a decay process, we can calculate this because before decay, this is 18 and equals to, this is Q plus R, right? So this is 18, this is 0 because we have memorized it for the positron particle. Then what would be R? R is going to be 18, okay? Then he says, explain how radioactive decay of fluorine emission from the body, gamma ray photon detected during the PET scan. Again, we have already discussed this. The answer is written over here. Positron and electrons annihilate each other. As I mentioned, we need to remember the process of annihilation, and the mass of particle becomes energy of the photons. This is what I discussed over here, that whatever mass of electron and positron is there, when matter and antimatter combine, they undergo annihilation, and their mass converts to energy, which is represented as the energy of the released photons. Since energy is conserved, whatever energy is before the reaction will be equal to the energy after the reaction. Okay, explain how the detection process, we discussed that as well, that we understand that what times will be used from that location to reach up to that detector, reach up to that position. We understand that, and we can use them to calculate the depth and the location of the cancer tumor. So arrival times, as I mentioned, we know the times are being processed, and the image is built up by because wherever the cancer, wherever the tumor lies, from that moment onward, we will be receiving very high activity from these locations, and from the rest of the body, the activity will be much less. So that is how we trace or locate the the part where cancer lies. So I would recommend memorizing the marking scheme of this question, and please make sure that the February-March 2023 paper, 2024, you also go through that, because I believe that there will be a question regarding PET scan. Again, memorize those answers, memorize those questions. They will help you in major in 2024.